you about function, and I believe to workshop. All right. So can you all see my screen? And I think you all can hear me, right? So if you can see my screen, just maybe give me a yes. All right, good. Okay. So I hope you all enjoy the class, and we should start right now. All right. So first of all, let me show. Okay, a function, but before we learn how the function is example in slide, or if you try to do two, then if let's say we have like 3 factorial, it's going to be 3 times 2 times 1. Okay, so if we have 3 factorial, it's going to be 3 times 2 times 1 equal to 6 here. And then if we are asked to use a program to calculate the factorial of a number, so I have provided a sample code here so that you can use it to find the factorial of a particular number. For example, I provided this sample code here to find the factorial of 3, which means that I want to find what is the 3 factorial, and then the answer should be 6. Okay, so I have declared 2 variables first because I want to use it in my program later on. I have declared the num variable with the value of 3 because I want to find what is 3 factorial. So this is a number that I want to find. And then for this factorial here, this is the variable that is going to store the result that I have later on. All right. And then we have included this for loop here. So why I include this for loop here, this is used to find the factorial of 3. So remember, for loop, we have to include 3 parts. The first part is the initialization. We have tried to initialize 1 to a local variable I here. And then for the second part, this is the checking condition. So we have to check, right, whether this I value is less than the num or not. If this is the condition is true, then only we can enter the for loop. And then the last part is the increment. Okay, and then after that, we will just start our checking. The first part is when I is equal to 1. Of course, this is the first part. And then we have to do the checking. 1, is it less than or equal to num, which is the 3 here? Of course, we know 1 is always less than 3, so the condition is true. Since the condition is true here, so of course, we have to execute the statements inside the follow. So what we have here, factorial equal to factorial times I. Then we have to find what is the current factorial is going to be equal to 1. And then what is the current I is 1. So 1 times 1 equal to 1, which means that right now, the fact, this variable fact here, named fact here, is storing the 1 value. Okay. And then after that, we will proceed to do the increment to the I variable. The I will change from 1 to 2. And then after that, we will do the checking again. Is the current I 2 less than or equal to 3? Yes, of course, this is true. Since this is true, we will enter the for loop for the second times, right? And then after that, we will proceed to execute this statement again. What is the current fact value, which is 1? What is the current I, which is 2? And then what is the resulting value, 1 times 2 equal to 2? So right now, the fact variable is storing the value of 2. It is no longer storing the value of 1 anymore. It is updated. Then we will go to do the increment to the I variable again. I become 3, and then we will check. Is 3 less than or equal to 3? Of course, the condition here is true. So since the condition is satisfied here, we enter the for loop again for the third iteration, which means for the third times. Then after that, we will just proceed to find what is the current fact, which is 2, what is the current I, which is 3, 2 times 3 equal to 6, right? And then after that, Again, we have to go to check, do the increment to the I again, I become 4. So right now, is 4 less than or equal to 3? Of course, this condition is false because this condition is not satisfied here. So that's why we have to proceed to execute to actually exit the for loop because the condition is no longer satisfied now. Okay, so right now, the fact variable here is storing the value of 6. And then we have done executing the statements inside the for loop. So we'll just come out and go to the next statement here. This is a time where we have to print out what is the factorial of 3. So it is going to find what is the value currently stored in this fact variable. It's going to be 6. So if you use this sample code here, it's going to help us to find the factorial of 3, this particular number, and then the answer is 6. Okay, so this seems a bit easy, right? But if let's say I ask you to write a code to find the factorial of the first 3 numbers, I want you to write a program to actually print out 1 factorial, 2 factorial, 3 factorial. And then we will go to the next slide here. This is a suggested solution to you. We may need to write the functional logic for 3 times. You can see that the first part is going to be used to find the 1 factorial. Second part is going to be used to find the 2 factorial. Third part is used to find the 3 factorial. Okay, but if I want you to calculate the factorial of the first 100 numbers, you want to find so we want to find 1 factorial, 2 factorial, 3 factorial until 100 factorial. So you can try to imagine how lengthy the code is. Are you going to write the same factorial logic again and again for the 100 times? So of course, this is not going to be efficient, right? So I'm going to show you another possible program here where we can try to actually use a program. We try to include the function, and then after that, so we can just try to use a program including the functions, and we can still produce the same output. So why? If you look at here, you can see that I have included a factorial function here. This is a factorial function. And then after that, if let's say I just write this function for only once in this program, I just write it once, and then it is why this can be used to produce the output of the factorial of the first 100 numbers, because it's going to be called for 100 times. We are going to, from the main function, we are going to pass down 1 to this factorial function. It will return 1 factorial to us. Then we will pass down 2. This function will return 2 factorial until the last number. After we have passed down 100 to this function, it will just pass back 100 factorial to us. So you can just try to do the comparison between these 2 codes here. With using the function here, it actually can help us to eliminate those duplicate lines of code. It can save our time. We can no longer need to write the factorial logic again and again. Okay, so this is what means by the function. Just now we know that for function, we actually try to divide a big complicated program into multiple smaller functions. So function is actually a block of code. Why? Because this is actually a code module. It consists of some statements used to perform a single task. For example, if you look at this example here, these few statements here are actually used to find the factorial of a particular number. So that's why we call it as a block of code used to perform a single task. And then after that, the second point here, the function is used to perform some repeated tasks. So this is actually being shown in the example earlier, right? We try to use the same factorial logic, and then after that, we just try to use this logic to find the factorial of the first 100 numbers. They are just going to do the repeated tasks. Or you can just try to use the function to perform some specialty tasks such as printing. I just want to call the function and then ask the function to do printing for me. So I can give you a simple example. You can just think of like you are the manager, and then after that, you just try to assign your colleague or maybe the workers to do some single job. So that's why you might assign the worker A, the function A, to perform the factorial calculation job. And then you might assign the worker B, the function B, to perform some printing job. So this is the idea of function. We try to divide the whole big program into multiple smaller functions. Okay. And then after that, we'll come to the next slide here. How can we just try to use the functions in programming? Of course, there are some advantages, right? So what are the advantages? Just now, we know that a function, we just try to divide it into multiple smaller chunks, where we call it as the multiple smaller functions. So this is what we call it as the modular code. If let's say we try to divide into multiple smaller functions. And then it will be easier for us to organize, to read, and to maintain it. Maintain means that if let's say we want to make some maintenance or maybe some improvement to the code, then it will be easier. We know that if let's say I want to do improvement on the printing job, the printing function, then we just go to the printing function and do some maintenance, do some modification there. So it will be easier for us to find it, to read it, and to do the maintenance. And then after that, we know that the program is divided into functions, and it will be easier for us to develop, to test, and debug the functions individually. So if let's say I ask you to make some changes to the code earlier, for example, I don't want to find the factorial of the first 100 numbers again, but instead I just want to find the double of the first 100 numbers. I want to show like 1 times 2, which means like 2, 4, 8 until 200. So you can see that instead of finding the factorial of the number, I just want to print out the double of a particular number. I just need to make the modification at one place only. If you try to look at the program with the function here. But if let's say, if you just look at the program without function here, are you going to write to make the modification at 100 places? This is not efficient. Right. So this is why the function will actually help us to do the testing, do the debugging of the function individually. We can just do the modification at one place. And then after that, the third advantage is the encapsulation, because we know different programmers like us, we can work on different functions simultaneously. So this can actually produce an efficient work. Right. And then the next part is the reusability. So what does the reusability means is that we can reuse the code multiple times. Whenever we need the function, we need to use the function. We just need to call it from anywhere in the program or maybe in different program. So we can understand this from the factorial example given earlier. Whenever we want to find the factorial of a number, we just call the function. We do not need to write the logic again and again for the 100 times. So you can also see that since we just need to write the logic for one time, and that we have actually eliminated those multiple line, duplicate lines of code. So this in turn will reduce the code size for us. It will just reduce the size of the whole program. Okay, then we'll move on to the next slide here. So just now we understand what is function and why we should use functions in programming. There are pretty much advantages that we can find, right? But now the question is, there is actually two types of functions that we are going to learn today. The first type is the predefined function, and the second type is the user-defined function. So before I proceed to discuss a little bit detail, if you try to look at the keyword, automatically you can have a hint on what is the function is. For example, the pre here, remember the pre means that something that has been done earlier. Okay, so for this case here, the predefined functions is actually the function that has been created earlier. Then if you look at the second function here, the second type of function, the keyword is user defined. User means us, right? The programmers, the developers. And then this means that this is the function defined by us. We are going to create the function ourselves, right? So the first thing I'm going to discuss about predefined function first. So for predefined functions, actually sometimes they will call it as the built-in function, or we can call it as the library function. Why we say so is that these are all the functions that are already defined in our system libraries. And we no need to write the function ourselves. We can just directly use this function in our code. So of course, these functions are actually defined in the header file of C++, like some C++ libraries. Then we can just use them, call the function directly. So let us move to the next slide. Is that how can we use the predefined function? So how to use the predefined functions in our program? The first task is that you have to include the respective header file. So what does this mean? Actually, you know, some predefined functions, since they are already defined in our system libraries, so you have to mention in your code what is the header file containing the definitions of this function, else you can't use that. Okay, so if you look at the example given here, we have the CMAX header file and CC-type header file. So this CMAX header file is actually a header file with some built-in max functions. So it will have some functions like power function, absolute function, square root function. So those functions that related to mathematics calculation. Then if you look at the second header file here, the CC type, actually this is the header file that has some functions to classify, to actually categorize or classify or transform the individual characters. So later on, we will come back to this more details later on. And then after that, after you're done including the respective header file, the next step is you just need to use the predefined functions directly. So remember these two steps here, include the header file and then use the predefined functions. So the next slide here is that I'm going to show you some examples of the predefined functions that we have right now. So there are going to be maybe just 11 functions here. Of course, you can find more online, but this is the main, I would say that those functions that are widely used. So this is the part that we're going to include in our program, the function here. And then I have also provided the header file, the purpose here, which means that what is the purpose of using this predefined function. And then I also provided some examples here so that you can understand more. So what is a return type? Return type means that if I call the function, what is the data type of the return value, which means that what is the data type of the resulted value after using the function. For example, if you look at the first one, the absolute function, since this absolute function, this fabs, right? This is actually defined in the CMAX header file because we know this header file actually consists of those max operation, max functions. And then the value of the arguments, the x here. When I talk about the arguments, the parameters, this is going to talk about the something inside the bracket here, the x here. For example, how can we use this function? You just have to put the function name, and then inside the bracket, you have to put in the arguments that you want to use this function. So if let's say I want to find the absolute value of negative 5.67, it's going to result in a value of 5.67 to us because it's going to convert the negative value to positive value. Okay, and then you know the resulted value, the data type, this should be something like double. This shouldn't be integer, right? So that's why the return type is actually mentioned about double here. And then we move on to the cosine function here. So I believe you have learned about cosine of the graph. So for this cos function is going to return the cosine value of the x. So if let's say cos 0, so of course the answer is 1. And then if we talk about the sine functions, we have the sine graph. And then when we have like sine 0, sine 180, sine 360, it's going to be return the answer of 0 to us. And then if we look at the next function, exponential function. So exponential function means that we want to find a value that e power x, right? So this is the e, which means that the e is equal to 2.718. So you just have to put in the argument here, the x here. It's going to return to you the e to the power of x. So if let's say I have the x equal to 1, so e power 1 is equal to 2.71828. And then we move on to the power function. Power function means that x power y, right? So it will return this x power y here. Of course, you have to include these two arguments so that it can return like x to the power of y. For example, if let's say my x equal to 0.16, my y equal to 0.5, then we have 0.16 power 0.5. Actually, this is something like the square root of 0.16, right? So it will result the answer of 0.4. Then we have the square root function. It will return the square root value of the argument x here. So square root of 4, we get the answer of 2. Then after that, we move on to the next slide here. So these two functions, C and floor function, again, they are defined in the CMax header file. And then after that, what does their C function works and what does the floor function works? Actually, if you look at this two function, they are going to return an integer value to us. But what kind of the integer value that will return to us? If you look at the C function here, C, maybe you can just think of like something ceiling. You know, ceiling is something above above us, right? So this means that if let's say we have provided an argument, the x value, so it's going to return an integer above the x value. For example, if you have like C function 56.34, so what is the integer that is greater than 56.34? This is going to be 57. And then after that, if we have the floor function here, floor means something that below us. So it's going to return an integer below this x value. For example, if we have floor 45.67, so what is the integer smaller than this particular 45.67? It's going to be 45. So this is what the C and floor function will work. Then after that, we move on to the isDigit function. For isDigit function, two upper function, these are the three functions that are defined in the CC-type header file, which means that it's going to deal with some characters, some digits, some letters. So if you look at the isDigit function here, which means that it's going to do the checking. Is the x value, the argument here, is it a digit or not? For example, if let's say I just try to check isDigit and then inside the bracket here, I put a 5. So of course, 5 is a digit, right? So it will return 1 to us. 1 in I would say that in computer, 1 here actually is representing true, which means that this 5 is a digit. Okay, if let's say you are actually checking either letters, which means like maybe you just try to put in characters which is not a digit, then it will return 0 to us, which means that this is false. Then after that, we have the two lower and two upper function. So two lower function, this is used to convert the characters into lower letter. For example, if I want to use the function here and then I just try to put in the uppercase letter H. So this function is going to help us to convert it into a lowercase letter H, right? So that's why the answer is the lowercase letter H here. Okay, and then after that, similarly goes to two upper functions. It's also done the similar job, but the question is, it will help to convert the character to uppercase letter. So it's going to help to convert this lowercase letter k into an uppercase letter k. All right. Okay, so for this case, we just move on. Just now I say you just need to include their respective header file and then use the predefined function directly. And this is the sample output that we will obtain right now. So give me a moment. Let us switch to the coding part so that I can show to you how can we use it in the C++ here. Okay, so this is an example here. We have include the header file right here. Okay, and then after that, this is the statements that we use that are, we just try to use a predefined functions in the program. So we look at the first one. We have used the power function, right? Of course, we have declared two double variables here. We have double x equal to -3.5 and y equal to 2. So if let's say we want to find what is the power of x and y, so it's going to return -3.5 power 2. Okay, so if you check, the answer should be 12.25. So you can just try to verify the answer using the calculator first before you proceed to run the program. And then after that, if let's say I want to check, I want to just try to convert the character from lowercase letter a into the uppercase letter a, so that's why I use the toUpper function here. So I would expect that the resulting value should be, the resulting character should be uppercase letter A here. Okay. So you might ask me why we want to do some casting here. Okay, so just now, if you back to the table that we have, you can see that if let's say you use the toLower and toUpper functions, it's going to return the value in integer form. So what does this mean? Okay, so for this case here, it means that if let's say you just use this toUpper function, it's going to return, it's just going to return the ASCII value of uppercase letter A to you. Okay, so ASCII value of A, this is not what we want, right? We just want to print out the exact character of this uppercase letter A. So you can do some casting to it. Just try to do the casting, change the data type from integer to character. I want to show the exact character. So that's why you have to include this part. And then after that, it's going to print out the uppercase letter A to you, right? And then look at the last part here, absolute value of x. So I want to find what is the absolute value of -3.5. So for this case here, what is the absolute value of -3.5? We just try to remove the negative sign, right? So it will become 3.5 here. Okay, so this is how we use the predefined function. And then of course, we just try to run it. Just give me a moment. Okay. All right, so you can see the answer here. -3.5 to the power of 2, it is 12.25. You can check it using your calculator to make sure that our program works correctly. And then the uppercase letter A is, this should be the uppercase letter A. And then since we do the casting, so it will show the exact character to us. And then the last part, absolute value of -3.5 is 3.5 here, right? So we don't need to write the function ourselves, but we just need to include the header file, and then use the function directly. This is what we call it as the predefined function. And then we back to our slide here. Okay, so the next one, we are going to move on to discuss about the user-defined function. So we are allowed to define our own function to reduce some complexity of the big program. And then this function, of course, is created by us, that it will provide the flexibility to us, like how are we going to write the program, how are we going to use the function. Next, to create a user-defined function, because just now, if you use the predefined function, we no need to create the function ourselves. But if let's say now we move on to discuss about the user-defined function, and then we have to learn how can we create the function ourselves. There are 3 parts that you have to include in your program. The first part is the function declaration. The second part is the function call, and then the third part is the function definition. Always remember to include these 3 parts. If you miss out any part of it, that it might cause an error in your program. Function declaration, call the function, and define the function. So I'm going to discuss with you the details of how can we declare, call, or define the function. But before that, let us try to look at the flow of the function in the program first. We understand the flow, then only we try to learn how can we write a program, how can we declare or call or define the function. So you look at this slide here. The first thing is, of course, we have the function declaration and then we have the function call here, right? And then actually this example is try to create a program to find the addition of two numbers. For example, if I have 36.5 and 20 here, I want to find the summation of these two values. And then I am expecting that the function will return or will just print out the answer of 56.5 to us. So this is the idea of this example, right? So then after that, we're back to here. So you see, we have the function call here. We want to call function. Whenever you want to use a function, you have to call the function. So the flow is like this, is that when the function is being called, the execution, let me use the pointer here, okay? The execution main function will temporarily stop here. So the main function is not going to proceed to execute any statement. When the function is being called, you can see that the control will pass from the main function to the function that we call. So this is what we call it as the flow control transfer. The control pass from the main function to the function we call. And then after that, it will just start to pass down some parameters because sometimes we have to pass down information to the function. If you try to, maybe we try to use the first example that we have, the factorial example. Remember that I need to pass down 1 to the function, then it only can continue to calculate 1 factorial. If I pass down 2, then it will calculate 2 factorial. If I pass down 100, it will calculate 100 factorial. So that's why you can see that we have to pass down the parameters sometimes. Sometimes we might need to pass down the values if the value is needed in the function. Sometimes we might not need to pass down any value if the function don't need the information to do the single task. Okay. Then after that, once the control has been passed to the function, we also done parsing down the values, then the function will start to perform its job. It will just start to execute any statements inside the function. It start to perform its job. Once the function does its job, then the control will pass back to the function, to the main function. Okay, so once the function does its job, either it will just return back any answer to the function caller here, and then at the same time, it will pass back the control back to the main function, the function caller here. Okay. So this is the flow. Just remember, we pass down the values information to the function first. Once it done performing the job, then it will just return back the control back to us. Okay, and then we will proceed to the first part. How can we declare the function? Just now we know how the function is executed, right? We call the function, then let the function to do its job. After that, the function will pass back the control to us. But how can we proceed to create the user-defined functions? Remember the first part, function declaration. Why we want to declare the function? The simple question, why we need to do so? Remember that if let's say I show you an example here. Remember why we want to declare the variables, why we want to put like double A equal to 36.5, B equal to 20 here. This means that you are going to tell the compiler that there are two variables that will be used in this program, especially in this main function, right? And then these two variables are double data type, which means that it can store those values with decimal places. This is the purpose of doing the variable declaration. So same thing goes to the function declaration. Why we want to declare the function is just the same as why we want to declare the variables. You just need to tell the compiler about the existence of the function. You want to tell the compiler that, okay, there is a function in this program. And then at the same time, you try to provide the information about the structure of the function to be used in this program. So what does this structure of the function mean? What does the structure actually consist of? What is the information that we want to provide to the compiler regarding the function? So there are three things that we want to tell the compiler. The first thing is, what is the return type of the function? What is the function name and what is the parameter list? Okay, so the first one, I'm going to start to discuss the function name first. You have to tell the compiler what is the function exists in this program. So that's why you have to provide a function name here. For the function name, you have to be careful. Every function, you need to make sure that you have name it with a unique name. We don't have any two functions in the same program that having the same name. This is not allowed to do so. Make sure every function is they will have their own unique name, right? And then after that, you look at the parameter list here. Remember just now I said to you, when we call the function, sometimes we want to pass down some information to the function, right? To do some function processing job. So for this case here, we have to mention how many parameters. Parameters, it just means like arguments here, like how many values that you want to pass down to the information to the function. And then what is the data type of the arguments that you want to pass down to the function? Okay, this is pretty important because you are going to tell the function that, okay, I'm going to pass down maybe 2 or 3 values. And then what is the data type? Is it an integer or is it a character? Then after that, we move on to the first part here, the return type. So what does the return type here mean? Actually, this is the type of value returned by the function. If you look at the next slide here, actually there are 2 types of user-defined function. We know sometimes the function may tend to return a value to the function caller, or sometimes it may not return a value to the function caller. So that's why we have 2 types of the function here, void function and value returning function. If let's say we have passed down there some arguments, some information, some values to the function, and then the function done processing its job, and then sometimes it depends on whether the function wants to return the value to us or not. If let's say the function does not return any value to the function caller, maybe in the main function, so we have to make sure that the return type is void. Void here means that return nothing, which means that the function won't return anything. It will just, after it does its job, it will just pass back the control to the function caller in the main function. All right. And then after that, for the second type of the user-defined function, if let's say today the function is going to return a value to the function caller. So of course, it's going to return only one value to the function caller. And then you have to indicate what is the data type, what is the type of the return value. If the function, after it does its job, it returns an integer to the function to the function caller in the main function, then you have to make sure that the return type is int. And then if let's say the function return maybe a double type value, then the return type is double. If the function return maybe the answer of true or false to the function caller, then the return type should be bool, which means the Boolean type. Okay, so this is what it means by the return type that we have to include in this function declaration. Return type, function name, and parameter list. Then we move on to show some examples of the function declaration. So we just try to look at the first part. This is the first example of declaring a function. If you look at here, double is the return type, which means that the function is going to return back a value with the double as the data type, right? And then after that, the addition here, this is the function name, which means that the function name is addition, and we know that there won't be any other functions with the same addition name again. And then this is the parameter list, the double here. Okay, so for this double here, we know that actually you can see that there are 2 double here, which means that we are going to parse down 2 values to the function, 2 arguments to the function, 2 values, and then the value is of double data type. Okay, then this is the explanation here, of course. addition function is going to take two double parameters, and then after it does its job, it will return back a value of double data type. So I have shown you another possible way of declaring the function. You can see that I put the x and y here. Okay, so the argument name, the x and y here, actually this is optional. You can choose to remain the argument name here, x and y, or you can choose to remove it, become double, comma double. Doesn't matter. Either way will work as well. And then we move on to the second example here. You can see that the void is the return type, right? Which means that the function won't return anything. And then the swap is the function name. And then the parameter list here, we have two integers here. So here we know that we are going to pass down two integers to the function. The function called swap. And then after the function done processing its job, then it won't return anything to the function caller in the main function. Okay, so this is how we interpret what kind of the function exists in our program by just looking at the function declaration. Okay, and then after that, you look at the third part here, void display and then empty bracket here. So if you look at the void here, which means that we know the function won't return anything. Void means return nothing, right? And then the function name here, display here, this is a function name. And then after that, we have the empty bracket here. So this means that we are not going to pass down any values, any arguments, parameters to the display function. After the display function does its job, it won't return anything back to the function caller as well. So the parameter list is optional, right? Okay, then after that, we move on to the second part, function call. We know how to declare the function. We just need to include the return type, the function name, and also the parameter list. And now we move on to discuss about how to call the function. So how to call the function, actually, this is the general syntax used to call the function. Before I proceed to explain this part, we try to look at the first point first. Actually, when you try to look at your own program, sometimes you can see that actually in our main function, right? This is a function. This is what we call as the main function. Then you can see that this is a return type, and then this is the function name, and then we know that this is not going to pass down any. This is not going to take any parameters here. Okay, so this main function will be called automatically in every program. Every program, whenever you try to run the program, the main function is the only function that will be called automatically. But if let's say today we have include some additional functions in your program here, so this function is going to be called. It can be called from anywhere in the program, right? So it can be called from the main function, or it can be called from other functions. If let's say your program maybe have like two additional functions, then you may just use one of the function to call other function. So this is the idea of the first point. And then after that, we look at the general syntax used to call the function. So if you look at the syntax here, this time we no need to mention about the return type again. What you need to do is that you have to mention what is the function name. The function name, which means that the name of the function. Okay, and then the parameter list. So the parameter list here, this means that you have to provide the information. What are the values? What are the arguments that you want to pass down to the function when the function is being called? So that's what we call it as the parameter list here. Okay, and then there's one thing here is that you have to mention what is the arguments that you want to pass down. For example, if let's say we look at the first example here. This is the void function. Remember, for the function, we have void function, which means the function won't return anything. And then we have the second function, value returning function, which means the function will return a value to the function caller. So I will provide you two examples here, like how can we call the function in void function, and how can we call the function in value returning function. So we look at the first example, the void function, which means that the function won't return anything. So if you look at the function declaration that we have here, the return type is void, function won't return anything. The function name is addition. And then the parameter is here to Dabber here, which means that we are going to pass down to Dabber parameters to the function when the function is being called. Okay, and then after that, we have the second part here, the function call. So for this case here, you see, this is how we call the function. Remember that we have to include the function name and the data, the parameter list, the data passed to the function. So I use the same addition example, which means that I just want to find the addition of two numbers. So what is the function name to be used in this function call? Of course, the function name is addition, right? And then what are the parameters? What are the values that we want to pass down to the function? Of course, we want to pass down the A and B. I want to pass down this two information to the function so that the function can do some summation job to us. Okay, so I will pass down A and B to the function, right? Then after that, you can see that when the function is being called, the control will be passed from the main function to the function here, addition function. And then at the same time, we will pass down this both A and B to this function. So that's why I put the pass parameter here. Okay, then after the control has been passed down to the addition function, after it done parsing down the parameter, of course, it will start to execute any statements inside this function, all right? After the function done its job, then it will pass back the control back to the function caller in the main function. So there's one thing that you have to take note here is that since this return type of the function is void, which means that the function won't return anything. So that's why you can see that I have actually tried to remove this return statement here. Okay, because the function won't return anything. So you don't need to include any return statements inside this addition function here. We just, after the function done its job, we just pass back the control back to the function caller in the main function. All right. So how can we call the function? You just need to include the function name and then the data passed to the function. These two information. Then after that, if we proceed to the second example here, we have the value returning function, which means that we are expecting that the function will return a value, a result to the function caller. Okay, so again, you look at the function declaration here. The Dabber is the return type, which means that the function will return a value of Dabber data type to the function caller. And then what is the function name? The addition here, right? And then after that, if you look at the parameter list here, we have two Dabber here. It means we are going to pass down two Dabber values to the function. Okay, then we look at the function call. So if you look at the function call here, you can see that this is the function call. We have included the function name addition here, and then include the data passed to the function, which is A, B. But there is an additional variable that we have included here, right? The result equal to. So why? Before I explain this one, we try to understand the flow first. Remember, when the function is being called, the control will pass from the function call here, the main function, it will pass the control to the addition function. At the same time, it will pass down the two parameters, right? A and B will pass down to these two functions. So this is fine, right? And then after that, the function will start performing its job. It will start execute any statements inside this addition function. After that, once it's done, it will just pass back the control to the function caller in the main function. But remember, since the Dabber is the return type, which means that after the function done performing its job, it's going to return a value of Dabber data type back to the function caller. So that's why we have to include a return statement here. You have to include this return statement so that you can return back what is the result back to the function caller in the main function. So that's why if you have the void function, we no need to include any return statement because it won't return anything. But if, let's say, you have the value returning function here, you are going to return a value back to the function caller in the main function, you have to include this return statement. Okay. And then after that, why, after we have done returning the value to the function call here, why we need to store the return value in a result variable? Why we have this result variable here? Okay, the idea is that if, let's say, today we have excluded this result, we didn't put in this result, then after we're done calling the function, we also get back the result, which means the return value. Then how can I print out the result in the main function? So for this case here, we try to store the return value in this result variable, so that later on, you can just try to use the cout to do the printing, because cout is mainly used to do the printing, right? So we use the cout to do the printing. It will find what is the value currently stored in this result variable, and then it will just show the answer to us. Okay, so either you have stored the return value in a result variable so that later on you can print out what is the value currently stored in this result variable, or I show you another way. For the same value returning function, if you don't want to declare the variable to store the return value, there is another possible way to print out the return value directly. You can see that I just use the cout here, and then I do the function call here. So that this is the function call, right? The addition is the function name, and then A and B, these are the data passed to the function. Okay, and then why we can just put in the function call in this cout statement here, because it's going to print out the return value directly. So you can see the difference. The first one, you try to store the return value in a variable, and then after that, you print out what is the value stored in the result variable. Or the second way is that you just try to print out the return value directly here. Okay. All right. And then after that, we will move on to the next part here. So just now I have discussed about the function call by using the C++ as the example. So I have also provided the examples in Java version so that you already can refer to it if, let's say, you want to learn more or you want to know how it is being done in Java. Actually, the concept is the same. For void function, you see that we don't need to include any return expression, which means like no need to include any return statement to actually return back the value to the function caller. Okay, and then for value returning function, so the same thing here, you have to make sure that you have indicated the return type, and then you have to include the return statement here to return back the return value to the function caller in the main function. Okay, so the concept is the same actually. Okay, and then we have done function declaration, function call, and it's time for us to move on to the function definition, the third part. Okay, so what does the function definition means? Actually, it's try to write the full body of the function. We try to include some statements that will be used to perform those repeated tasks or specialty tasks. Okay, and then we try to look at the general syntax used to define the function. There are three things that you have to include here: the return type, function name, and also the parameter list. So actually, this is what we call it as the function header. Okay, for function definition, you have to include the function header, the three things here, as well as the function body. So we try to look at it one by one. If you look at the function header here, actually, this is something similar to your function declaration. You have to mention about what is a return type, the value returned by the function, the data type of the value returned by the function, what is the function name, and then after that, the parameter list. So for this parameter list, a little bit different is that you have to mention the number, which means how many parameters that are going to be taken by the function, what is the data type of each argument, and then what is the name? What is the name of the argument? Okay, because during the function declaration, just need to mention the number and the type. But for the function definition, you have to mention the number, the type, and also the name. right? And then after that, inside the function body here, this is something that's pretty important for us. This is where we have to include some variable declaration, why I say like local variable declaration here, it means that we try to declare some variables that can only be used within this function only. Okay, and then we also include some function body statements. We just try to put in some codes that can be used to perform a single task. And then after that, the last one, the return statement. Remember, if the function is a void function, it won't return anything, then you can remove this return statement. But if let's say the function is a value returning function, then of course you have to include this return statement. All right, so now you know for function definition, don't forget to include the function header and also the function body. Then we move on to the first example. I'm going to discuss with you 4 examples to show you how can we define the function correctly. So we look at the first one, the same thing. We just try to start with a simple example. I want to find the addition of 2 numbers. All right, so you can see that again, the return type is void, which means that the function won't return anything. The function name is addition, and then 2 double here, which means that we are going to pass down 2 parameters with double as a data type to the function. Okay, and then after that, we have the function caller here. Remember, we have to include the function name, the addition here. And then after that, we have the 2 parameters here, A and B, which means that we are going to parse down 36.5 and B equal to 20 to the function. And then the last part, this one is what we call it as the function definition. We have the return type, the function name, the 2 parameters. Remember that we have to include the argument name X and Y. Okay, so for this case, you can put X, Y, you can put A, B, doesn't matter. You can just put it any name that you want. And then after that, of course, we have to include some statements inside the function. All right, then we just try to look at how this program will work. So the first thing is the function is being called, and then remember that the control will pass from the main function to the addition function here. It will just pass the control from the main to the addition function. And then at the same time, we know, right, A and B, these are the 2 informations that will be passed down to this addition function. So it's actually telling us the order. You can see that the A will be passed down, the A should be the 36.5, and then it will be passed down to the first argument, which is X. And then the B, which is equal to 20, is going to be passed down to the argument in the second position, the Y here. Okay, and then after that, it will just proceed to execute any statements inside the function. So it's going to find what is the addition of 2 values. It will find what is the summation of these 2 values, and it will print out the answer directly. After that, once the function done its job, it will pass back the control back to the main function. But since the return type is void, which means that it won't return anything to the function caller. So that's why I put the 3rd point here. No value is returned to the main function, to the function caller. Okay, then we just try to move to the coding part, because I want to show you how it actually works. So just let me show you here. All right. Okay, so we look at this part here. This is a function declaration. This is the function call. And then after that, this is the function definition. Very clear, right, and direct. And then if you look at the part here, we have declared these 2 variables because I'm going to use it in the main function. That's all. And then we have called a function. We are going to pass down A equal to 36.5. I want to pass down A equal to 36.5 and B equal to 20 to the function. So the function is being called, right? And then it will just pass the control to the addition function here. So we know 36.5 will be passed to X, and then B equal to 20 will be passed to the Y equal to 20 here. Okay, then their statements inside the addition function will be executed. So we can see that it will print out the addition of two values is, so it is going to find what is the value of x plus y. So what is the value of x plus y? 36.5 plus 20 is going to be 56.5, right? And then it will print out this, the addition of two values in is 56.5 as the output. And after that one is done its job, it won't return anything to the function caller, and then it will just end the program. So we try to run it to see whether we can get the correct output or not. All right, so you can see that we have the output here. The addition of two values is 56.5. Okay, so this is the output. Then we're back to here. We try to look at the function again. So the idea is we pass down two values and then do the printing of the summation of two values in the addition function. And the function return ending back to the function caller in the main function. Okay, then we move on to the next example. So if you look at the next example here, actually, this is also a program used to find the addition of two numbers. But the difference is that this is a void returning function. You can see that the return type is double. And then after that, the function name is addition. Then we parse down two double form values to the function. Okay, and then what is the function call? Remember, for void returning function, either we can store the return value in a variable, maybe like the result here, or you can just use the cout to do the printing of the return value directly, right? So for this case, this is the function call here. We have the function name addition, and then we have the two parameters A and B that are going to pass down to the function. So again, the last part, this is the part that we have the function definition. We have the function header, and then after that, we have the return statement here. Okay, so the idea is that once the function is being called, the control will be passed from the main function to the addition function. And then at the same time, the A and B again, these two informations, these two values will be passed down to the arguments to the x and y in the addition function. So again, 36.5 passed to x and 20 will pass down to the y. Okay, then it will just try to return x plus y, which means that it's going to return the summation of these two values back to the function caller. Okay, so it will return the 56.5 to the function caller here, and then we know the return value is 56.5. This is a number consisting of the decimal numbers, so that's why we have used the correct return type double. Okay, if we use the integer as the return type, it's going to return 56 only, which is wrong. Okay, make sure you use the correct return type to return back the value correctly. So after it done returning the answer back to the function caller, so the control will pass back to the main function. Then we try to look at the coding part. Okay. So if you look at the coding part here, you see this is a function declaration. This is the function caller here. And then after that, this is the function definition. So we try to look at this part because for the function caller here, we have to pass down A equal to 36.5 and B equal to 20 back to the addition function. So right now, the result, it won't have any value yet, right? Because we haven't done calling the function, so it won't return any value to us yet. So any output will be eliminated first. Okay, and then after that, 36.5 will be passed down to the first argument x here. 20 will be passed down to the second argument y equal to 20 here. And then their statements inside the addition function will get executed. So it's going to return x plus y. So it will return, and what is x? 36.5 plus what is y, which is 20. So it's going to return 56.5 to the function caller. So after that, it will return back the return value 56.5 to the function caller here. And then remember, we will store the return value in a variable. So that's why now result is equal to 56.5. Okay, because the function done its job, it done finding the summation of two numbers, and now it's time to get back the answer from the function. So right now, the result is storing the value of 56.5. Then after that, it will just proceed to execute the remaining statement in the main function. So it will just print out the addition of two value is the result. So it will find what is the value currently stored in this result variable. So it's going to be 56.5. All right. So we try to run it to verify the answer. Okay, so you can see that the output is the addition of two values is 56.5. Right. Okay, so we're back to here. We know that actually this is a value returning function. It just tries to return back the result to us, and then we will do the printing of the result in the main function. Then I want to show you another example here, example 3 here. So this example 3 here, actually we try to extend a little bit of the second example that we have just now, which means that here we are going to add 3 numbers instead of 2 numbers. Just now we try to add 2 numbers, right? But here, right now in this example here, we try to add 3 numbers, okay? So again, you can see that this is the function, the new function declaration. We have the double addition 3 double here, which means that this addition 3 function is going to return the value of double data type. The function name is addition 3. And then there will be, we are just going to pass down 3 parameter values to the addition 3 function. Okay. And then how about the function caller? Since this is a void returning function, right? You can see that we have the function caller here. This is the function name, and these are the 3 parameters value that we are going to pass down to the function. So again, later on, we will store the return value in the result variable so that we can do the printing of the result later on. Okay. And then after that, what we have here, we just try to understand the flow first. So the first thing is when the function is being called, it will just pass the control from the main function to the addition 3 function. Okay. Then at the same time, it will pass down the parameters. 36.5, which is A here, will be passed down to the X. B is equal to 20, 20 will be passed down to the Y, and then C is equal to 15, 15 will pass down to the argument in the third position, the Z here. Okay, so right now we have X is equal to 36.5, Y is 20, Z is 15. Then after that, once it done parsing down the parameters, we will try to execute any statements inside this addition 3 function, right? But if you try to look at the return statement here, we have, actually, this is what we call as the nested function call. Why I say so? Nested function call means that we can find a function we can find a function within another function. So for this case here, you can see that we have an addition function within another addition function here. Okay, so this is what we call as the nested function call. So usually how can we deal with this kind of the nested function call is that we have to settle those operation, those function inside the bracket first. In other words, it means that I have to call the addition function the inside the bracket first. I'm going to pass down the 20 and 15 to the addition function first. Okay, settle the inner operation first. So we know that 20, this time here, the addition function will be called, and then 20 will pass to the X here, and 15 will be passed to the Y here. Okay, and then after that, it's going to return X plus Y. So it's going to return 20 plus 15, which is 35, to the function caller here. Okay, so this function is being called, and then after that, it will return back 35, which actually makes sense, right? The return type is double. This is still correct. It will return back the 35 to the addition YZ here. Okay, so right now we have the first argument 36.5 and second argument is 35. And then after that, don't forget we still have the outside and external function here, addition 36.5, 35. So again, the addition function will be in core again. And then this 36.5 will be passed to the x, the argument, the first argument x, 35 will be passed to the second argument y. And then again, it's going to return what is x plus y to the function caller here. So what is x plus y? 36.5 plus 35 is going to be equal to 71.5. So it will return back 71.5 to this function caller here. And then this is not the end yet, right? Because this is the addition tree function being called. So eventually 71.5 will be returned back to the function caller here and being stored in this result variable. Okay, so let us try to move on to look at the coding part. Okay, so this is a bit more complicated if you try to compare with the second example, but we can understand the flow, right? The first part is we are going to pass down a 36.5, 20, and 15 to the addition tree function. So we have x equal to 36.5, y equal to 20, z equal to 15 here. But remember, once it called the function here, we have addition. The first argument is 36.5. And then we have the second argument, which is addition, y and z, 20 and 15. Okay, so I say to you, we have to settle the inner function first. So that's why 20 will be passed to the x here in the addition function. And then 15 will be passed to the y here. Okay, because this addition function being called, 20 passed to here, 15 passed to here, and then it will return x plus y. So what is x? 20 plus 15 equal to 35. So 35 here will be returned to this function call. So eventually this one is going to get back the return value of 35. Then now it's time for us to settle the external function here. Again, with addition function again, 36.5 will be passed to the x here. 35 will be passed to the y here. And then it will return what is the current x? 36.5. What is the current y? 35. What is the resulting answer? 71.5. Okay, then it will return back this 71.5 to the function caller here. So we have 71.5 here. But remember, this is the value that we are going to return back to the function caller in the main function. So 71.5 will be passed back to here. So we have result is equal to 71.5. Okay, then after that, what we have here, now the result is storing the value of 71.5. And then when you try to print it out, it's going to print out, okay, the addition of three values is, so it's going to find what is the value currently stored in this result variable. So it's going to be 71.5. Okay, then we try to run the program to make sure that we get the correct output. Okay, so this is the output that we have here. The addition of three values is 71.5, correct. So back to my slide here, you can see that we just try to include a new function, and then after that, we use it to find the addition of three numbers. Okay, so this is a nested function call. We have to settle the inner function first, then only settle the external function. All right, so I think we have done for the first session, and then you all may return back to the main room here, and then we will just come back for the second session later on. All right. Okay, thank you.